Thanks for joining us today for Lean Bites. I'm Jason Buck. I'm a business development director here at Lean Techniques. If you're joining us for the first time, welcome. We're glad you're here. Lean Bites are a short 16-minute talk where our experts provide simple, practical tips and techniques that you can start applying within your organization or team today. So before we get started, a couple of things. Number one, if you have any questions throughout today's talk, drop them in the chat. And we can either address them at the end if time allows, or we can offer more insight in an email follow-up to you as well. And number two, please do us a huge favor. At the end once you close out of the Zoom, a survey will automatically pop up. And if you could provide us any kind of feedback, what you liked, what you might want to see in the future for Lean Bites, that would really help us out. So without further ado, I'd like to introduce one of my favorite people, Patrick Robinson, who's a staff engineer here at LT. He's joining us from our San Antonio contingent. And Patrick's been a vital part of helping software teams thoughtfully and effectively adopt AI. And he's going to be speaking to us today about keeping AI on mission for more reliable software delivery. Patrick, take it away.
Yeah, no, yeah, I'm going to talk about there's a helpful strategy. I'll go ahead and put up the agenda slide. We're going to talk about why AI can get it wrong. I feel like a lot of us have probably experienced AI getting it wrong a lot, but also a couple of mindset shifts, as well as a helpful strategy and how and when to use that strategy to help you in your quote unquote vibe code journey. What I would like to say on the top end is we're not actually talking about vibe coding, but there is a book that has come out recently called Vibe Coding. We're using that term loosely. So if I ever say vibe coding, I'm jokingly referring to vibe coding, just as a caveat. But we'll start with why AI can get it wrong a lot. Now, you probably all have experienced hallucinations. And if you're not sure what that is, that's basically where AI kind of makes up something and is very sure that it's correct. I think also some reasons why AI can get it wrong. This list isn't an exhaustive list, but is prompting AI, just by its nature, is non-deterministic. Like you ask it something, it can give you a different answer if you ask the same question multiple times. And then also something that we've seen with some teams that we've coached with AI delivery is giving too much context over time starts to confuse AI, starts to cause those hallucinations. And also we don't always know what we want. That's a common problem is we don't know how to articulate what we want from AI when we're asking it to give us something or to do something for us. And then also sometimes the problem is just complex and just one-shotting or few-shotting, if you're not familiar with those terms. Basically, if you don't give it examples or give it some examples, but like the problem might be too complex for a simple example. And if you see a comic picture, it was AI generated. So if there's any typos, it's entirely my fault for letting it slip through the human in the loop. But yeah, so I want to then jump into mindset shifts. So given that we have problems with AI, I want to bring up some shifts in mindset that might help with our journey with AI. So there's this book by Gene Kim and Steve. I don't know how to pronounce his last name. I'm going to go with Yegi because I don't know how to pronounce his last name. So I'm sorry to Steve. But basically, they bring up in this book, this book kind of goes through journeys of them going through and vibe coding and finding things that don't work. They've deleted source code, all the problems and things that they've gone through. But one of the things that stood out to me near the beginning of the book was this concept of thinking as if you were to equate coding to like cooks in the kitchen. And so you go from being a cook to being a head chef. And that mindset, so like now you set the menu, aka the requirements. The agents do kind of the prep and cook effort, the actual execution of the dish, and then you are in charge of the standards and tasting, acceptance checks. But at the end of the day, ownership stays with you. And so kind of the mindset shift here is that with AI coding assistance is you want to delegate tasks, but you own the dish or you also own the outcome. So anything that's generated by AI, you own, you are the owner of it. And so that's where the original term vibe coding, for me, has a bad taste in the mouth. Is that the original definition was like not even caring about the code or the infrastructure, just telling AI to do it. But with what we're going to talk about today is you own the outcome, you own the dish. And then also a few other mindset shifts that I want to talk about is seeing AI as a pairing partner, as an entity to brainstorm with. Also, there's a couple of concepts that come out of a book that I'll have a link to the book at the end, but it's called AI Engineering by Chip Huyen. I don't know if I pronounced her last name correctly as well, but there's a concept called AI as judge, where you use an AI or LLM to validate or invalidate the output of another LLM. And so that's kind of a cool concept where you're using AI to judge AI's output. One of the fun ways to do that is to kind of take the output from one and then bring it into the other one and say, a colleague of mine generated this document. Can you poke holes through it? But using AI to kind of judge is a clever way to sort of help filter out. And I wouldn't say it doesn't prevent hallucinations, but it helps to mitigate some. It helps to find some hallucinations. It helps to do that. And then there's this concept called a mix of experts. If you kind of think of having multiple personas for agents, you could sort of think of them as like a board of directors would be an example where each board member is an agent persona, and like you could pick some famous person that you could probably generate a persona for, and then have a group of them, and then ask the group of agents questions or throw ideas out, have them poke holes. And so then you have a bunch of different viewpoints, either poking holes or maybe even encouraging you along the way. And this is not an exhaustive list either. This is just a few details to kind of get us ready to jump into the helpful strategy. And what this helpful strategy is, I'm terrible at naming things, but it's a three-step process called research, plan, and implement. So I call it the RPI strategy. I'm not the first person to say those words in that order, but I'm going to kind of do a high-level overview of this strategy. But I really want you to kind of think or ask yourself this question of like, what if we use AI as a thinking partner when we're faced with that complex problem? Or what if we use AI to help us research, plan, and implement a solution? And my thought process with this strategy comes from how an engineer probably either thinks or collaborates. So if you were to take the research step, given some ticket or problem or something, you would probably research the code base, go to Stack Overflow or nowadays ChatGPT or Claude or whatever, and ask like, hey, like how do I solve this problem? And like, where would I actually make some of the changes in my code base? And so, kind of doing the research, you probably would do that on your own anyway. And so, using AI, incorporating AI into that process to help you do the research, have it delegate and go look up useful resources, look through the code base to find areas of code where I might need to make this change, and then validating it using AI as judge. And then moving on to the plan process. As an engineer, you probably would take the time of researching the ticket and then the code base. Then you might either write it down or you might actually just keep it all in your head and go take the plan and think through how am I going to update this code base? And then you go and implement the plan. So we're going to kind of dive a little bit deeper, not too deep, but a little bit deeper. The research process, I have a sort of a simplified flow chart over on the right, but basically you start with a problem, use AI to help you clarify the problem, bounce ideas off, brainstorm, take that problem that you've clarified, analyze your code base, have AI go and fetch resources online, have it come back with the links so that you can go and look into it further. And all of this culminates into generating a file for being able to document the research. And part of the secret sauce to some of the RPI strategy is clearing the context between each phase. And so that document is going to kind of help mitigate, keep us from getting too much context so that AI hallucinates all over the place. It doesn't completely prevent it, but it helps to reduce the severity of hallucinations, or at least the maybe even the I don't know what the word is I'm trying to frequency. There we go. Frequency of hallucinations. So basically, you start with a problem, then we build up a fact base, and then we want to also validate it. I like to use what I call the FAR scale, is have a rubric for is the information factual, actionable, and relevant to the problem in the code base. You could probably create your own type of scale, but that's kind of what I have run with whenever I do research is try to analyze how factual it is and actionable and relevant. But outputs the file, and that goes straight into the plan side of things. And we take that research output and we start a new context window if you're in GitHub Copilot, you do a new chat, or if you're in Claude Code, you clear and then you do the planning part where you basically map out a multi-phase approach depending on how complex the problem is. Basically, each phase should have very small tasks. So having a multi-phase approach with tasks that I like to call atomic, basically kind of along the lines of a CLI command call, create a file, add a test, very small things that are like a one action step kind of a thing, aka atomic, and then synthesize this plan. So basically, this whole process for the plan side of things creates a document that if you were to go and do all of the checklist items in order, theoretically, when you've checked off the last checkbox, the entire plan has been implemented, done, ship it. That's the theoretical part of this part. But now, this file that gets created from this one, guess what? Gets sent into the implement process. So now the plan file, again, this is all to mitigate context rot or bloat by having too much in the context window. So now you have a research document and then a plan document. The plan document has just enough information for the implement phase to be able to have your AI, whichever one you're using, Copilot or Claude or whatever, going in and it looks at just the next open task and then it performs the task and then exits and then clear the context and do it again. I like to think of the clearing of the context in the implement step like you have a high caliber software developer that's showing up. They've already got their first coffee down, they're caffeinated, they're ready to go, they're already in flow state. And that's what I like to think of whenever I think of the context window being cleared, and then you give it just enough context and one checkbox task item to do at a time. And what you do is you validate the output right when it happens. So part of the idea behind this is it also keeps the human in the loop at the tightest feedback loop that I could think of. And that's as each task is done, you validate it, you review, maybe make some changes. You can either chat your way through it or you can code the changes and then clear your context and move to the next one. And what that does is you're actually validating the output at smaller intervals. So you're kind of getting that context along the way rather than having one giant PR of like 1,000 line changes at the end and wondering what the heck did AI just do. If you're there along the way, you'll build that context and you're keeping it on track by like noticing, hey, I didn't like this change. Let's go fix that. And at any point, if the plan changes, you can then go update the plan and go back through that process by going back to the plan step and then back into the implement step. And so that's at a very high level the RPI strategy. And so how and when to use it? Well, I'll start by saying I did help coach a team that they wanted to use the RPI strategy to generate a README. I will tell you right now, that is not what it's designed for. It will do it, but it is definitely overkill. It's really meant for complex problems, for you to help break down a complex problem into bite-sized chunks and then keeping AI on track with the implement step. That's where that small tight loop comes into play and keeping AI on track by doing a little bit of work at a time and doing it well and getting just enough context. But yeah, I also used AI to generate that person kind of looks like me. But yeah, so you don't need to use RPI for everything. I was just going with the analogy of when all you have is a hammer, everything looks like a nail. Um, but yeah, updating a README or writing a simple unit test or something like that might be a little overkill for it, but maybe something like adding a new API endpoint and then integrating it into the front end or something might be something to follow patterns that exist in the current code base. So yeah, with that, I've got some helpful resources. I'm sure these slides are going to be sent out in some form or fashion, but there's a YouTube video that I watched, I think it was May or June when this Y Combinator video came out about advanced context engineering. And it does talk about research, plan, and implement, and gives like a really high level, quick overview of it. But I went and like looked up the repo and dove into a lot of stuff and did a lot of research around like validation. So my flavor of the RPI process strategy it has that validation and the human in the loop iterative implement step, and then the book. And then there's also a little link to something if you want to listen to some good rock music while you're quote unquote vibe coding. And then we also have a blog post that covers this in a little bit more detail as well. But with that, thank you.
That's awesome. Thanks so much, Patrick. And do yourself a favor, make sure you click on the music to vibe code too. It's pretty fantastic. Thanks for all attending. Take care. Have a great day.